Hello viewers, welcome to my channel. I'm Hasham Khan. Now I'm going to start a new subject, that is statistics for management. In this subject, totally 5 units I'm going to cover up. The 5 units are: unit number 1. What is the meaning, definition of statistics, origin, development and application of statistics in business management? First topic. Second, measure of central tendency, measure of dispersion, skewness and kurtosis. Third one, probability. The meaning, definition and theories of probability, multiplication theorem, addition theorem, joint probability, conditional probability, Bayes theorem. That's all. So these are the topics in unit number 1. Unit number 2. Random variable and theoretical distributions, binomial distribution, Poisson distribution, normal distribution. These are the topics in unit number 2. Unit number 3, sampling, different types of sampling, hypothesis testing and procedure in hypothesis testing, and large sample tests, Z test. So these are the topics in unit number 3. Unit number 4, t-test, small sample test, chi-square test and analysis of variance, ANOVA. These are the topics in unit number 4. Last and final unit, unit number 5, correlation analysis, regression analysis and time series. So these are the different topics under different units I'm going to cover up. But first of all, I have selected a small, easy to understand topic so that you can easily, you don't find any difficulty in understanding. That's why a small chapter, small topic I have selected. That is measure of central tendency. So in this video, I'm going to explain you about measure of central tendency and arithmetic mean. In the next video, I'll explain about median, mode, geometric mean, harmonic mean, right? So before explaining about what is this measure of central tendency, take a screenshot of the points which I have written on the board, then I'll explain all the points. Come on viewers, now I am going to start measure of central tendency. Measure of central tendency is the study of averages. Study of averages. An average is a single value which represent a mass of data. So in our daily life, personal life and public life, we depend on average. It's a single value which is representing a huge data. Simple example, if you go to purchase grapes, all the grapes are there, but you have to take the decision whether grapes should be purchased or not. You are taking only a single grape and testing it. If it looks quite sweet, then you take the decision to purchase it. That means 1 is the average you have taken. In this way, averages are very important because we take a number of decisions on the basis of average. A single value which represent a huge mass of data. The study of averages is called measure of central tendency. A single representative value of a mass of data is called average. Just now I told you. Then the study of averages is called measure of central tendency. And average is a single value around which all other values will congregate. It's the middle value around which other values will congregate, will be surrounded. Then the purpose of computing an average value for a set of observation is to obtain a single value which is representative of all the values. So the main purpose why we calculate average, so that we can be able to find out what the characteristics of all the items which is represented by a single item. So average is a single value which represents a whole series. The complete data will be disclosed by a single value. So this is the meaning of the term measure of central tendency, that is measure of averages. That's it. Now objective of calculating average, why we calculate average? Some few examples I have given here. Represents the characteristic of the entire mass of data. Because we cannot study all the items, we need only a single item which is representing the whole item. So that's why we need averages. Second, to facilitate comparison. If you want to compare two groups, two mass of data, simply we take average of first group, average of second group. Comparing the average, we can be able to give the conclusion regarding comparison of the whole data. Next, to describe the data. By studying the average, we can be able to get the complete description of the whole data. Next one, to quantify relationship. We can find out the relationship by calculating the average. Next one is basis for further analysis. Average is very important because other measures, other statistical measures require averages. Example, for calculating standard deviation, for calculating correlation, for calculating regression. So for all these further studies, we require average. Without calculating average, we cannot get standard deviation, we cannot get correlation, we cannot get regression. Next one, to facilitate sampling. In case of sampling, in unit number 3, I am going to explain you about sampling. What is sampling? But right now, remember, averages are very much used in sampling. So these are the objectives or uses of averages. Now, limitations of averages. There are many advantages of averages, but there are few limitations. So what are the limitations of averages? First one, misleading conclusion. When we come to some conclusion on the basis of average, the conclusion may be misleading. The conclusion may be wrong. For example, if in a particular place, the temperature, the highest temperature is 48 degrees and the lowest temperature is 2 degrees. 48 degrees highest, lowest is 2 degrees. If we calculate the average, 48 plus 2, 50. 50 divided by 2, 25. So we can say the average temperature is 25 degrees. But if a person decides that the average temperature is only 25 degrees, he will proceed there. There he come to know that the temperature is around 40 degrees. That means his conclusion is wrong. He thought that average temperature is 25. But when he come to the particular place, the temperature has gone up to 40 degrees. It's very, very hot. So it is misleading. Sometimes the average may be misleading. Secondly, choice of average. There are many methods of calculating averages. We have to choose a particular method which suits our purpose. Next, incomplete picture. The average will not give the complete picture. It is not necessary that the characteristics of the average is the same as the characteristics of the whole population. Next one is absurd conclusion. Sometimes the conclusion given by average will not be realistic. Example, when we calculate the average number of members in a family. Suppose the average number of members in a family comes to 4.5. But it is not possible. The average number may be 4 members or 5 members. We don't have fractional members. Like this, absurd conclusions we may get. So these are some of the limitations of averages. Now, characteristics of a good average. If you want to calculate a good average, what the characteristics of that average should be? First one should be rigidly defined. The definition of average should be precise, should not be ambiguous, should not be confusing. So the definition, meaning of that average should be clear, rigid. No two meanings should come out. Next, easy to calculate and simple to follow. The average should be easy to calculate. Very complicated formula should not be used. A simple formula should be used. Easy to calculate, simple to follow. and it should be based on all observation. Nothing should be left. The average should be calculated by taking all the values of the set. No observation should be left. It should not be affected by extreme values. Suppose there are some extreme values, ignore that extreme values and then calculate average. Next one is, should be capable of further processing. The average should be such that it is capable of further processing, further statistical technique. It can be used. So these are some of the characteristics which must possess by a good average. Next, types of averages. So far I have explained you about the meaning of the term measure of central tendency, average, objectives, limitations. Now, methods. What are the different types of averages? The averages, there are many methods of calculating the average. But the most popular methods are arithmetic mean, AM, median, mode, geometric mean, harmonic mean. These are the very frequently used averages. Then first of all, one by one, we will study. First one is arithmetic mean. Arithmetic mean is the most widely used average. Normally, whenever we say average, it means arithmetic mean only, because it is more widely used. So what is this arithmetic mean? Arithmetic average, or simply mean of a series, is the figure obtained by dividing the total values of the various items by the number. We take the total of all the values divided by number of items. Example, suppose some 10 students are there. All the 10 students have written the examination. Every student got different marks. First student got 40 marks. Second student got 50 marks. Third student got 20 marks. Fourth student got 80 marks. Like the different marks are scored by 10 different students. Now we need the average. So how to find out the average? Take the total of all the marks scored by 10 students. We write down. First student 40, second student 50, third student 20, fourth student 80. Like that we take the total of all the marks, dividing by number of students. How many students are there? 10. Suppose the total of the marks are 450. The total marks scored by all the 10 students are 450. And how many students are there? 10 students. So 450 divided by 10. You will get 45. So 45 is the average. 45 is the arithmetic mean. So take the total of all the items divided by number of items. That is called arithmetic mean. In other words, it is the sum of values divided by their number. Sum means total items, total values divided by number of items. Arithmetic mean is the most widely used measure of central tendency. Just now I told you, if you compare all other averages, the most frequently used average is arithmetic mean. Now, calculation of arithmetic mean. How to find out? How to calculate arithmetic mean? See here, there are three types of series: individual series, discrete series, continuous series. Individual series means no grouping is made. Simply we write down the values. Simply if we take the values, it is called individual series. Suppose if we make a group with frequency, that means X values are there, frequency is there. That is a discrete series. And continuous series means where we have class interval and frequency. The class interval like 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Like that it goes on. That is called class interval. The class interval and frequency is given. It is called continuous series. Three series are there. For every series we have different formula. So first I am explaining about individual observations, discrete series, direct method. Two methods are there, direct method and indirect method. The direct method formula is X bar. X bar is nothing but the arithmetic mean. The symbol for arithmetic mean is X bar. N is equal to number of items. Summation X is equal to total of all items. So X bar is equal to summation X by N. This is called arithmetic mean by direct method. Now shortcut method, X bar is equal to A plus summation D by N. A stands for assumed mean. So before calculating, first we will take the assumption. Any one of the value we treat it as assumed mean. So take the assumed mean plus summation d by n. Summation d is the total of deviations. We take the deviations of all the item from assumed mean and take the total. That is summation d. This is shortcut method. So these two formulas are there. X bar is equal to summation x by n. This is the direct method. And shortcut method is assumed mean plus summation d by n. That's it. So individual observations method I have completed. Now discrete series. In discrete series, direct method x bar is equal to summation fx by n. We multiply frequency with x values. Frequency with the variables. Divide by n. Shortcut method a plus summation fd by n. F stands for frequency. D stands for deviations. So multiply frequency with the deviations. Divide by n. Now continuous series, direct method summation fm by n. Here we have taken summation fx by n. Here I am taking summation fm by n. Mid values. M means mid values. Upper limit plus lower limit divide by 2. Like 0 to 10. So lower limit is 0, upper limit is 10. So 0 plus 10 divided by 2 is 5. So 5 is called the mid value. The shortcut method a plus summation fd by n. A stands for assumed mean, f into d, frequency into deviations, divided by n. So these are the formulas for discrete series or continuous series. So for individual observations, discrete series, continuous series. Or these are the formulas we have to apply to calculate arithmetic mean. Now combined mean. If two or more groups are there, we can combine the group and calculate the combined mean. Two groups are there. For example, two classrooms are there, A classroom, B classroom. Suppose 50 students are there in A classroom, 50 students in B classroom. So we have two groups. We want to combine both and calculate the combined mean. The formula for combined mean is x bar 1 2 is equal to n1 x bar 1 plus n2 x bar 2 divided by n1 plus n2. So these are all the formulas I am going to apply in the coming videos where I will solve the number of problems on combined mean. Now points to be noted while calculating arithmetic mean. Some points you have to remember now itself, so that while doing the problem there should not be any confusion in your minds. If the class intervals are given in inclusive series, first convert it into exclusive series and then calculate arithmetic mean. What is inclusive series and what is exclusive series? I am showing it here. Suppose if the values are given 0 to 9, 10 to 19, 20 to 29, 30 to 39. This series is called inclusive series because we are including lower limit and upper limit in the class. The first class is 0 to 9. So 0 is included, 9 is also included. Second, 10 to 19. 10 is included, 19 is also included. That's why it is called inclusive series. Suppose if in the problem inclusive series is there, you have to convert it into exclusive series and then only you calculate. Exclusive series will be like this: 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, like this. This is called exclusive series. Why we call it as exclusive? Because we are including the lower limit and excluding the upper limit. In this 0 to 10, 0 is included, but 10 is not included. 10 will be included here. Second class, 10 will be included. 20 will not be included in this second class. 20 will be included in the third class. 20 to 30. 30 will not be included in this third class. 30 will be included in the fourth class. So lower limit is included, upper limit is excluded. That's why this series is called exclusive series. So if in the problem inclusive series is given, you have to convert it into exclusive series and then only you calculate the arithmetic mean. How to convert it while doing the problem, I'll explain you. Now, if open-end intervals are given, first convert it into class interval and then calculate arithmetic mean. Open-end classes. The first class and the last class will have open-end. For example, less than 10, greater than 70. First class is given less than 10. Last class is given greater than 70. So first class and last class are called open-ended. So we have to convert that open-ended into class interval and then calculate the arithmetic mean. Third one, if midpoints are given, then first convert them into class interval and then calculate arithmetic mean. In some problems, midpoints will be given. So convert the midpoints into class interval and then calculate arithmetic mean. How to convert the midpoints into class interval, I'll explain while doing the problem. That's it. So in this video, I have explained you about the meaning of the term measure of central tendency, what is average, what are the characteristic features of average, and what are the uses, objectives of making the average. All these things are explained. And what are the methods of averages? Arithmetic mean, median, mode, geometric mean, harmonic mean. The complete formulas I have given for arithmetic mean. In the next video, I'll explain about median, mode, geometric mean and harmonic mean.